It's Matthias Neu again, and I should like to show you real quick how to configure a piezo charm. As an asset monitor in delivery state comes with no configuration, so it needs a setup for the piezo charm to specify what type of sensor is connected and how the input needs to be considered from the charm itself. So for doing so, we have been moving into the charm section, and you see that all my charms are unconfigured. So I'm just pressing onto the piezo charm for moving into the overview page of the charm itself and see that this charm is not configured. So we now either can click on the configuration button over here, or we can go to the general configuration button that is also available after a charm has been configured if you'd like to change anything to the configuration. So I'm just clicking over here, and you see that we're automatically moving into the one-page configuration that is required to be set up for the piezo charm and specification what type of sensor is connected finally. So the first checkbox here you see is the enablement checkbox, which comes automatically activated per default, but we are able to deactivate a charm, for example, if a sensor is defective and we want to exclude that from the measurement anyhow. So we can check the box for disable or check it again for enablement of the single charm, the piezo charm. After that, we see at the basic section of the configuration parameters that it is just for descriptional reasons. So we can enter a name, which is per default the charm and slot, charm number 1 at slot number 1, just shown from here. For a description, we can call it, that's optional parameters, description and cabling ID. So for description, I'm just entering the type of sensor here to show anything. So it's an accelerometer. And cabling ID could be any type of number, so a point ID or a cabling ID, whatever it is required to be entered over here. So I enter just anything into. And finally, we go into the details section. So here we are able to specify a sensor name, and if clicking into the field, it automatically gives us a recommendation. So I'm just changing it to channel 1 piezo sensor. It's the type of sensor I have. And from sensor type perspective, we know that there are accelerometers and velocity types, so we can easily choose from sensor type. If it is an accelerometer or velocity type of sensors that we have connected, so we're going with the acceleration here. And sensitivity, definitely a value you need to read from the manual or the datasheet of the sensor itself. So for my type, it's a 50 millivolts per G. Sensor type, so I'm just entering that over here. So from functionality perspective, we can specify how the evaluation should be happening inside of the piezo charm. So it can be acceleration measurement, as we have connected an accelerometer, but if clicking onto that, we see a table that it could be zero peak, peak to peak, or RMS evaluation for acceleration. But the charm itself is also able to do an integration, so it could also show the values in velocity directly by using an accelerometer, also in zero peak, peak to peak, and RMS. And last but not least, we're also having opportunities to use peak view from here, so it can be activated inside of the charm that it is on board without any additional cost of licensing or any specification in ordering from a part number perspective. So for keeping it easy, I'm just going with the peak-to-peak acceleration here for showing anything. And last but not least, from the overview page and detailed section, it's a signal filter opportunity where we're able to specify the signal frequency range at the input stage of the charm. That could be just a band pass, low band pass up to 600 Hz, a medium band pass up to 5 kHz, or a high band pass up to 20 kHz. So let's go with whatever is required. Now from hardware perspective, as we're supporting the ICP sensors, two-wire ICP sensors, that we definitely should ensure that the sensor is powered up by a current driven into the sensor itself. And this can be managed by the piezo charm itself as well, so we are able to activate the current supply from the checkbox over here. So if having the box checked, we see a second field that allows us to enter a current driven into the charm. And for my simulation over here, I'm just lowering that to 1 milliamp. Typically, those sensors are supplied by currents in range 4 to 8 milliamps, so I guess it's up to 8 milliamps is available from here. On the lower part, we're seeing three different voltage levels. So it's a signal full range specification in volts, it's a DC bias range in volts, and the AC measurement range in volts. And this specifies finally the overall range, AC plus DC. It's a signal full range where our signal could be in, and this is exactly where the channel OK recognition inside of the charm is looking after, together with the DC bias range, which can be typically in range 4 to 16 volts per default, but you can lower that if you want to. So for my simulation, I'm just lowering that to 10 volts um, if I want to, and like to go with the DC voltage down to 1.5 volts, which is a minimum value to be entered in here. And an AC perspective is the vibration level of the signal. So that's finally what the piezo charm is looking to from evaluation perspective, from understanding of vibration levels. So it could be in range -4 to +4 volts finally. So this is the maximum value to be entered in here. And on the lower part, we also see a display, and that means that not automatically the overall page or the overall range that can be measured by the charm needs to be used for display purposes, as the expectation could be much lower in value, but we definitely want to ensure to see a large amount of vibration finally. If it comes into the charm from the sensor perspective. So we're able to limit our display range for having good resolution on bar graphs and displays inside of the Asset Studio finally. So for me, I'm just going down to 10 Gs to be shown as a scale for all the displays. But as said earlier, we're still measuring in the full range page of the sensor finally. So last but not least, after having all these configuration parameters set up, we're just pressing the save button and it's saving the data into the charm. And after a few seconds, while the charm is now starting up, we will see that the data driven into the charm after a sensor is connected will appear automatically. So if you see after waveform and spectrum appears, we have opportunities for the waveform to enlarge the view by just pressing the magnifying glass plus button over here to see the waveform in more detail. We have opportunities to scale the time basis of the display. Could be just 10 milliseconds, 50 milliseconds, or 100 milliseconds. And as you see on spectrum page, we only have the magnifying glass as the frequency base of the diagram is fixed. So we're able to press a magnifying glass to have a scaling of the display a little bit larger for better resolution finally. And that's how to configure a piezo charm.